Hey there and welcome. In this video we will talk about search algorithms, sequential search and binary search. First, sequential search here. If we take the pointer, let's have a look here. Pointer, laser pointer. This is a really basic algorithm. It goes from the start to the end and it's going to work for both unsorted and sorted list. It's a linear algorithm, meaning that it's basically constructed using a loop, as we will see later on. And this also means, regarding the performance, that if we double the size of the list, we also double the search time, because we need to go through all the elements in the list here. And if we take a look at the algorithm, it's pretty simple. We can see that we have a for loop and we will look at every index from the first to the last. So worst case is going to be big O of n, because we will look at all the entries in the list. And then we have a simple if statement. If it is the same as the value we're looking for, we're going to return it. Okay, otherwise -1. The sequential search also comes in a generic version where we can see that we've defined the T type, and that means that it can work for all kinds of objects, as long as they will be objects, because they need to have the equals. So it's not going to work with primitive types. We need to actually put them in a wrapper if we need integer. Then we're going to state that we are going to return int, which is the index. Return the index for the found value, otherwise -1. And otherwise it's going to work the same way, where we're using equals, the basic function that comes from object that will check if two objects are the same. Okay, so that is the generic version of that. We also have other search algorithm, and one of the most common and mostly used is binary search. And as the name implies, it is an algorithm that will use the divide and conquer paradigm. So it's going to take a look at the list, and then an important thing to note here is that the list must be sorted. So the binary search first needs to have a sorted array or collection of some sort. So that of course also takes some time. But then we can see that when we have a sorted array, it is really fast, because it will, at each run, it's going to narrow down, take half of the size of the array, and then it will look at this. So if we're looking for 21 or 19, as it states here, we can rule out 1/2 of the array and just only worry about the right half of the array. And then we can take this array and use the algorithm on, and then it's going to do the same thing again. So 19, is that in the left or the right part of the new array? And we can see we always calculate the middle. So this time it's in the left part, so we throw away the right. And each and every run we are halving the size of the array, and that means that this is a logarithmic algorithm, base 2 logarithm. So the good thing about that is, if we double the size of the list, we only add a small constant to the performance time. So this algorithm is really fast when we have a sorted array. Okay, so here we can see the iterative version of the binary search algorithm, and it is constructed using a while loop. And the place that is most clear, where we can see the divide and conquer, is that we will adjust the middle index. That will determine if we're looking at the left or the right half. And we do this at each iteration, where we calculate the middle, and then we take a look, because it is sorted, then we take a look if the middle value is bigger than the actual value we're looking for, and otherwise we're going to adjust it. And the binary search also comes in a generic versions, where we have modified the method header a little bit. The signature of the method, we can see that we actually state that there should be a type T that needs to extend the comparable interface or implement it. So the type that we input here must either directly implement comparable interface or extend from a class that implement comparable. So this is basically all comparable items. So you can use your own BE entity, your own custom classes, if they implement comparable. We can see that we're using compare_to down here, and also in the bottom of the algorithm. So we need to ensure that the type actually implements comparable in some way. So that kind of concluded what I wanted to mention about the sequential search and the binary search. In the next video, I will make a short demonstration of how we can actually use these algorithms. So take care and bye-bye.